Hi everyone. We're going to find reference angles in degrees. A reference angle is an acute angle, which means it's an angle between 0 degrees and 90 degrees. Okay. Quadrangles are not reference angles. Okay. The only reason we like to use reference angles is, for example, when we are completing the unit circle, if you know quadrant 1, then you can get the rest of the quadrants just by changing the sign of your x and y values. So that's why reference angles come in handy. Here are the formulas for the reference angles. We'll be talking about that more. I'm going to do 6 problems. And this is for AP class, pre-AP class, or you could say a pre-IB class. So these are not easy sometimes. The first one we're going to do is negative 115 degrees. All right. First of all, it doesn't follow our criterion that before we use this formulas that our angle has to be in between 0 and 360 degrees. So what I'm going to do is I'm going to make it coterminal by adding 360 to this. And when you add 360, you get 245. So now if we look at this, I'm going to draw a quick drawing. This is 0 degrees. This is 180 degrees. This is 270 degrees. And this is 90 degrees. Our angle is in quadrant 3. Once you know that angle, then all we're going to do is use this formula in quadrant 3. And we're going to take 245 minus 180 degrees, and you subtract that and we will get minus 180, 65 degrees. So our reference angle is 65 degrees. So let's look at, I'm just going to draw it a little bit. Our angle is 245. I'll put it right about there. All right. And basically all you have to do is draw up to the x-axis. This was 245 here, 245 degrees. You draw up, and this would be 65 degrees. Sorry. Another way to think of it is when we did our unit circle, you could continue this on. And remember when we made the bow ties? I'm not going to do that again, but this point here, they're both positive. My x is positive and my y. So the reason we want another reference angle, the reason we want a reference angle is because if we know what it is in quadrant 1, then all we have to do in quadrant 3 is make our x and y both negative. And we don't have to keep computing. So in the future I won't draw these. We're just going to use the formulas. The next one we're going to do is 225 degrees. All right. That belongs to quadrant 3. So I'm going to take 225 minus 180, and you should get 45 degrees. So 45 degrees is our reference angle. Again, we did 225, and I'm doing this quickly. Here's your 225 angle here, and if you draw up to the x-axis, this would be 45 degrees. Okay, the next one is 400 degrees. It doesn't lie in between 0 and 360. Therefore, we're going to go ahead and subtract 360, and we get 40 degrees. Now, 40 degrees already belongs to quadrant 1. So 40 degrees is our reference angle. That's our answer. The next one we have is negative 715 degrees. So it definitely does not lie between 0 and 360 degrees. So I'm going to subtract 360 twice, which is, I will not subtract, I'm going to add. I'm going to unwind my angle and add that up, and I get 5 degrees. Since 5 degrees belongs to quadrant 1, 5 degrees is our reference angle. Okay, 2 more. I'm going to split this in half. We have 825 degrees. It does not lie in the proper between 0 and 360 degrees. So I subtract 360. You should know that's not going to be enough. So you subtract again, and you get 105 degrees. That lies in quadrant 2. So what we're going to do is we're going to take our formula for quadrant 2, which is 180 degrees minus theta. So that's 180 minus 105, which gives us 75 degrees. And the last one we're going to do is 500 degrees. We're going to subtract 360, make it coterminal with 140. That means it has the same value there. 140 is in quadrant 2, so I'm going to use this same formula here. So 180 degrees, should have done that, minus 140 degrees equals 40 degrees. 40 degrees lies in our range here, so well, it's in between, sorry, and 90 degrees. So that's our reference angle. The next video I'm going to do is reference angles in radians, and they're the tricky ones where you're going to have some decimals and everything.